Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to get started on chapter number 5. Yes, we are already on chapter number 5. Seems like we're just cruising right through this book, and there's only 12 chapters, so we're almost halfway there. So keep working hard, do your best. Chapter number 5 starts off on page number 154, page 154. What we're going to do in this chapter. Now, this is a cool chapter because it only has 4 lessons, only 4 lessons. So we're going to go through this really quickly, but we're going to be able to spend some time on each lesson to hopefully help you to be able to get each one to where you kind of know what to do. I'm not going to be able or have to rush through them. The first one talks about and kind of defines what the whole chapter is going to be based on, and it's called systems of equations. Systems of equations. If you look down here at the screen, I have a system of equations. What does that mean? Here's what it means. It means when you put 2 equations together, that's all it means. You're building a system. Now, you could have 3 equations together, 4 equations together, 5, 6, a million, okay? A system is just more than one equation. Now, notice that they're connected together. You always write systems of equations like this, one on top of the next, okay? And we'll kind of see them in our book pretty much all the time, just written like that, one on top of the next. And when they're like that, you know, okay, I'm dealing with a system of equations. So, how do you solve systems of equations, or what is a system of equations? Well, a system of equations is basically when you put 2 or more lines onto a graph. So if I have a graph down here, if I put one line, for example, like this, that's, you know, when we graph a line, when we use our x and y and all that, we get a line. Well, a system of equations is just when I put 2 lines or I put 2 equations onto the same graph. Okay, and you've seen this before. You've seen this in newspapers, on TV, maybe in the baseball statistics or something where they put, you'll see different lines on top of each other showing you different things. Well, what they're doing is they're using a system of equations to show you information. So we're going to learn how to do that in this chapter. The first thing I want to talk about is what is the solution to a system of equations, okay? The solution is where those 2 lines touch each other. I'll just put one line here and I'll put one line here. If you'll notice, they touch each other right here. Let me get a different color and show you. They touch each other right here. This is the solution to this system of equation. Now, let me zoom in just a little bit. Where do those 2 lines meet? Well, they meet at, remember, this is the x and this is the y. And so they meet at 1 on the x, so 1 on the x, and then 1 on the y. 1, 1 is the answer or the solution to this system of equations. Now you might think, well, that's pretty simple, it's pretty easy, so this is going to be an easy chapter. Well, that's just the start of the chapter, the idea, the concept. We're going to do a whole lot of different things in the chapter, but this is the base concept. So when you see the 2 lines touch, that is the solution, where the 2 lines are touching each other. All right. If you will, go ahead and look in your book on page 154, and I want to solve this system of equations. Now, here's what I'm going to do. I'm going to do something. We're going to kind of do this one several different times in several different ways. In the first example, what they do is they give you this system of equations, and then they say, are these solutions or are they not solutions? And so they give you this. They say 2, 1. And they want you to say basically, yes, that's a solution, or no, that is not a solution. How do we do this? Well, remember, this is the x and this is the y. Okay? And so what we're going to do is we're going to plug the 2 in where we see an x. We're going to plug a 1 in where we see a y. And we're going to do that on both of our equations. We're going to do that separately. So let's do it on the first one. So 2 times 2, because that's the x, plus 3 times 1, because that's the y, equals 12. Now here's what we want to do. We want to solve this, and we want to see if this is true or if this is not true. And so let's go ahead and see what happens. So 2 times 2 is 4, plus 3 times 1 is 3, equals 12. 4 times 3 is 7. 7 does not equal 12. Okay? And so we can say immediately, as soon as we have one that doesn't work, okay, we could say then this doesn't work. So this is not a solution. 2, 1 is not a solution. Now, you could also, if you want to, plug it into the other one. But you don't have to. You can stop right there because you've already got that it doesn't work. It only has to not work in one. If it doesn't work in one, but it works in the other one, so let's say this one did not work in this one, then it's not a solution. Well, what happens if it does work in this one, but it does not work in this one? Well, let me show you what that looks like. So let me leave that there. All right, so the next one we're going to try is 3 over 2, comma 3. You know, I'm going to put 1.5. I think most of you like decimals better than fractions. 1.53. Okay, so our x is 1.5 and our y is 3. So everywhere we see an x, we're going to put the 1.5. 2 times 1.5 plus 3 times 3 equals 12. Now we have to see, does this work? What is 2 times 1.5? Well, that's 3. 3 plus 3 times 3 is 9 equals 12. 3 plus 9 equals 12. 12 equals 12. Hey, we got the right answer. So that one works. Now be careful, because that does not mean that this works. You're like, oh yes, it worked. No. We have a system of equations. So what we have to do now is we have to say, okay, it worked in one. Let's see if it's going to work in both. And so what you'll do is you'll come over here to the next one, and you'll substitute it into this one, and we're going to see if it's going to work in that one. So we'd have 3 times 1.5 minus 3 equals 7. All right, what's 3 times 1.5? You might need to come over here and do that, or do that on your calculator. 3 times 1.5 is going to give you 15, 3, 4.5. 4.5 minus 3 equals 7. Oh, 1.5 equals 7. No, 1.5 does not equal 7, okay? And so this one does not work. The second one, it worked in the first one, but it did not work in the second one. And so that means that this one does not work. When we get one of the systems of equations that does not work, then it's not an answer, okay? And so then they give us another example. Let me go ahead and erase this real quick. And they give us another example, and it's right there. If you're following along, it's on page 155. And they give you 3, 2. So our next one that we're going to try is 3, 2. What does that mean? That means that the x is 3 and the y is 2. So now we're going to plug this into the first one, and we get 2 times 3 plus 3 times 2 equals 12. So 2 times 3 is 6, plus 3 times 2 is 6, equals 12. 6 plus 6, 12 equals 12. All right, cool. We got that one to work. Now we need to see if the second one will work. Okay, so the first one worked. Let's see if the second one will also work. All right, so now we're going to plug this back into this second one. So we're going to have 3 times 3 minus 2 equals 7. 3 times 3 is 9 minus 2 equals 7. 7 equals 7. Hey, good news. We finally got one to work. Now notice it worked on both of them, And so we would say, yes, this one works. We finally found the solution. That is the solution. That's where those are going to intersect each other. That's where they're going to cross on the graph. So now that we have our solution, let's go ahead and just verify our solution. Let's go ahead and graph it and see what happens on the graph. So you say, well, how are we going to graph this? Well, how do you graph these things? There's different ways to graph them. I personally like graphing with the y-intercept. Maybe you like graphing a different way. Maybe you like the x and the y intercepts. I'm going to use the slope-intercept form. 2x plus 3y equals 12. I am going to put that into the form y equals mx plus b. Okay? That's slope-intercept form, and I can graph from that form. And you need to remember how to graph from that form. This is going to be important right here, because it's going to save you a lot of time if you can remember this. So what are we doing? We're trying to get y by itself. How do we get y by itself? Well, let's move the 2x to the other side. Subtract 2x from both sides. And we're going to end up with 3y equals negative 2x plus 12. Divide by 3, divide by 3, divide by 3. We're going to divide everything by 3 because we're trying to put it into slope-intercept form. It's going to cancel. We're going to get y equals negative 2/3 x. That's our slope. And then 12 divided by 3 is going to give us a positive 4. That's our y-intercept. That's our b. Okay, that's our y-intercept. So now we can come down here to our graph, and we're going to graph this. So what are we going to graph this? We're going to graph this at 4 on the y. So 1, 2, 3, 4 on the y. And that's our intercept. Now, how do we graph the slope? Well, it's a negative 2/3, and so we're going to have to go negative on the 2. Remember, the slope is y over x, right? Okay, so we can go negative, we go down 2 over 3. So if we go down 2, 1, 2 over 3, 1, 2, 3. Here's our line. So now we're going to go ahead and draw our line through here. Now, my line's not going to be perfect, but I'm going to try to get it as close as I can because it's going to be kind of important that I get it close, because we're going to have to look and verify our equation, our system of equation, based on where does this line touch the new line that we're drawing. So, all right, so I did that one in yellow. So that's the first one we graphed. Now we have to graph the second in the system of equations. And I'll do that one in pink so that you can see where it's crossing. So now we're going to do this one right here. Again, we're going to put it in the form y equals mx plus b. So to do this one, I want to get y by itself, so I'm going to move 3x to the other side. That's going to cancel, and I'm going to get negative y equals negative 3x plus 7. I'm going to divide everything by a negative 1 because I need to get y by itself. I can't have negative y, so that's going to cancel. I'm going to get y equals negative negative, so that's going to go positive 3 over 1. I kept it as a fraction because it's slope. I like to see slope as a fraction. That helps me out. And don't forget that's a negative 1 there, so that's going to be minus 7. So here it is right there. Here's my here's my second equation. So I'm going to graph this with the pink line. So we're going to start at negative 7. That's our y-intercept. So go down here, and we're going to go 7 down. So 1, 2, 3, 4, 5, 6, 7. There's our y-intercept. That's where it crosses the y line. And then let's go back up here, and our slope is going to be 3, 1, positive. So up 3 over 1. Up 3, 1, 2, 3 over 1. All right, so here's our second point. All right, now I need to go ahead and extend my line there. All right, now notice where it crosses. It happens to cross where we had a point, but it's not always going to cross where we had a point. That's not the most important thing. What did we find out? What did we figure out? We figured out that it crosses at 3, 2. So let's go ahead and see what we got. 1, 2, 3, 1, 2. We verified it. We verified that 3, 2 that we checked earlier is indeed the solution for this. When we put our lines on here, so this is line number 1. The first line was the 2x. And you can actually label this if it helps you. This line is the 2x plus 3y equals 12. And this pink line was the 3x minus y equals 7. Okay, so I just labeled those lines. That's going to help you see which lines are which, especially if you're using a pencil or something where you don't have the colors to show which line is which. So basically I took this line right here, this 2x plus 3y, and that's this one. And then I took this other one, the second one. Let me get rid of this. This second one right here, and that's the pink line down here. Okay. And then when I graphed them, I ended up with the point of intersection where they crossed was right there, and this is 3, 2. 3, 2. 3, 2 is the solution to this. Okay, that is our solution. Now, let me show you one more thing real quick, and I'll be done with the video. All right, so this is our solution. Now, let's go down and let's look at different types of solutions, and this is on page number 155 in your book, 155, types of solutions. You can have 3 different types of solutions here. You can have what's called intersecting lines. That's what we just had. This type of equation will have a point where they intersect. It will have one solution only. It's called consistent. Okay, this is all in your book. You just have to memorize these things for now. We'll talk about what they mean a little bit later. And it is an independent solution. In other words, it doesn't depend on anything else. They're independent of each other. Now, the second solution set that you can have is what's called parallel lines. Sometimes your lines never cross. Notice here, these lines never cross each other. They just continue going in one direction forever. And so they're never going to cross. In that case, notice there is no solution. Why not? Because they never cross. Okay, so there's no solution. These are called inconsistent when they don't cross each other. That's inconsistent. They don't work together. It is a system of equations, but it's an inconsistent system. And then they are independent of each other. The last one over here is called coincident. Coincident lines. Now this is going to be a new term for you. I know you know intersecting, I know you know parallel, but coincident. What does that mean? Notice that the lines are right on top of each other. There's 2 lines there. Okay? Sometimes the equation will give you the exact same line. When it does, you just graph it. Here's what's going on. Look. That point's the same, that point's the same, that point's the same, that point's the same, that point. Every point is the same. They touch each other in every single point. Notice that you have infinite solutions. They cross, every single point is a cross. Okay? They're on top of each other. It is what's called a consistent because they consistently have the same answers. And it is what's called dependent. Again, we'll get into that in just a few more lessons. We'll talk about that just a little bit more. If you need to look at any of that stuff, it's on page 155. I know there's a lot of information packed in there. I told you that these lessons are jam-packed. There's short lessons. There's only 4 in the chapter, but they're long lessons when it comes to the amount of information that's in each lesson. So, All right, if you missed anything there, make sure you go back, rewind it. This would be a great video to watch 2 or 3 times maybe because of all the information that was jam-packed in there, and it's a lot of new information, okay? So take your time, study your book, do your practice problems, work through this. Make sure you message me if you have any questions, okay? We'll see you later. Bye-bye.